So we were discussing this refraction, and till what question we discussed in sheet number 4? Question number 11. Is there any problem from previous classes that you want to discuss? It's all good? So question number 12. Sheet 4. Does it need a diagram? Yes. Show me the question. So yes, this is the diagram. There is an object here, and it is at a distance of 15 centimeters. Given this information, try to do the question. I am giving you 3 minutes. Attempt the question. I will start at 12:01. Please write name at the top of the sheet so that it doesn't get displaced. Compared to the questions that we did last time, this is fairly easy. Any answers? Option A. That's correct. So let me start with it then. It's given you have a point object placed in front of this, and the radius of curvature of this thing is mentioned now. What is that going to be? 30 centimeter plus or minus? It should be plus. What about u? Minus 15 centimeter, right? Given this information, they are asking to find the image would be formed at what position. So they are asking B. And I think mu of glass is mentioned. What is mu of glass? That's 1.5. Yes. So what formula to apply? Mu2 by V minus mu1 by U, that's equal to mu2 minus mu1 by R. Now what is mu2? That's glass, right? So 1.5 divided by V minus 1 divided by what is U? Minus 15. 0.5 divided by R is what? 30. This will become 1 by 60, I think. 1 by 60. 1 by 15 plus, that goes there, becomes minus 1 by 60 minus 1 by 15 is what? Something like minus 1 by 20 maybe. Huh? Check it by calculations. So this is 3 by 2b minus 1 by 20, and then 2 ones are 2 tens are, and I think you will get something like b is equal to minus 30. Just a single formula question. You can't go easier than this. If you're done with this, go for question number 13. I don't think there is a diagram for 13. 14 का diagram. Is question number 12 written? Question 14 diagram I am making here for people who want it. 14 का diagram is something like this. This is given question number 14 and this is question number 13. I will do it. So I will start question number 13 in 2 minutes. Please attempt. Okay. Anybody did 13? Yes. What is the answer? B. What is B?
3.1.
3.1 is correct. Anybody else with the answer? Yes, correct. That's not 1 by B, that's B. I got some answers for 13. Should I start with it? It's a fairly simple question. It's saying that rays of light which are coming from infinity hits our this lens, which is the retina in this, and then focuses somewhere. Then what is our eyes? What kind of surface it is? It's a convex surface. Our eyes. It's given that the rays are coming from infinity and then they meet somewhere. And where do they meet? You have to find that distance. You have to find that distance. So what do you have to find? V. Yes or no? You have to find the image distance. So here V निकालना है. V is equal to what? What is the mu given here? What is mu given here? 1.34 here. 1.34 correct? And here mu is given to be 1. This is mu1, this is mu2. What is u? The rays are coming from infinity. What is u? I'll say something, don't be dead like that. U is infinity. Good. What is radius of curvature? To be more precise, it's minus infinity. What is radius of curvature mentioned? 7.8 millimeter. Should I take that positive or negative? Positive. Positive, right? In this direction. Then let's apply the formula and let's try to get the V. So it's mu2 by V minus mu1 by U is equal to, let me apply the formula directly. Mu2 is 1.34 by V minus 1 divided by infinity. That's equal to 1.34 minus 1 divided by 7.8. Say this goes to 0 and you will get something like V as 1.34 multiplied by 7.8 divided by 0.34. Can you do this decimal calculation? Or do you want me to do it? It's all good, you can do it. Then you will get something like 31 here, 31 millimeter. But I think the answer is in terms of centimeter, so you will get 3.1 centimeter. it okay? Approximately. It's not exactly, but approximately. Such a simple question. Question number 13. If you have done 13, now the interesting part is question number 14. Again a very simple question, but let's see who can do it. 12:11. I am giving you 3 minutes. At 12:11, I will start with 14. Attempt all the things that I have done. क्या हालत बना के रखी है? Any answer for 14? How many refractions are occurring in 14 by the way? Two refractions. So you have to apply how many times the formula? Be careful with that. There will be a virtual image due to the first refraction that will act like a virtual object for the second refraction. Yes? Attempt. By the way, the options for 14 are incorrect. So please change the options. Take new options. 1 by 2, 1 by 3, 3 by 4, and 4 by 3. 3 by 4 is incorrect. Tukka maro. Answer now. 1 by 2, 1 by 3, 3 by 4, and 4 by 3. Good. I got one answer. Anybody else? So I am starting with the question now. It's given that this is a refraction that is, let me give some names as well. So let me give this point to be B. This is C. For surface AB, there will be a refraction. For surface BC, there will be a refraction. For surface AB, what are they asking by the way? M, no? What is the value of M? We will apply what we know. What do we know? The formula. mu2 by v minus mu1 by u is equal to this and that. And then let's try to relate. So for surface AB, what is u? For surface AB, what is u? Minus mr. It's minus mr. What is mu1? What is mu1? 1. What is mu2? 3 by 2. What is the radius of curvature of this surface? That's infinity. You remember I talked about that if you have a plane surface, then it can be thought of as a very small segment of a very huge sphere. And that huge sphere can be considered as an infinitely big sphere. So R is infinity. Yes? And then let me try to find B. Then what will B be? So mu2, that's 3 by 2 by V1 minus 1 by minus mr. This is equal to 1.5 minus 1 divided by infinity. This goes to 0. So what is this? Minus 1 by mr. And what is V1? V1 is equal to minus 3 by 2 mr. You understand why negative? Negative means it's a virtual thing and it will be somewhere here. No? 3 by 2 mr. Here I find my image I1. How will this image I1 act as? That will act as an object for this surface now, BC surface. For the surface BC, can you tell me the data? What should be U? For surface BC, what is U? Minus 3 by 2. This minus 3 by 2 mr. And do I have to add anything? Plus R. Because this is from this surface the refraction is occurring, no? And we found this from this surface. So the actual distance should be minus 3 by 2 mr minus R in that direction. No? It's like 3 by 2 mr plus R in the opposite direction, negative sign. Then what will be R here? What will be R for this surface? Plus R or minus R? Should be minus R. Minus R. What will be mu1? What will be mu1? That's 1.5. What will be mu2? 1. The rays are going parallel to this, so will they ever meet? They never meet. They go to infinity. Then what is V? V is equal to infinity. I have all this information. Let me apply it in the formula and then let's see what we will get. Then what do you get? Mu2, that's 1 by infinity minus 1.5 divided by minus R 3 by 2 m plus 1. Yeah? This should be equal to 1 minus 1.5 divided by minus R. This goes to 0. There is nothing here. What will this become? I think this will be 1 by 2 R here. Please check. 1 by 2 R. Okay. And then what will you get? 3 by 2 R, 3 by 2 m plus 1. This will be 1 by 2 R. I think this will cancel. And then what will you get? 3 is equal to 3 by 2 m plus 1. This you will get as 2 is equal to 3 by 2 m. And then m is equal to 4 upon 3. See, we found the condition of m. M has to be equal to 4 by 3. How we found it? By applying what we know. What do we know? this formula. This is the only formula that we know, and we have the data. Let's apply the data and we'll find something or the other. Is it all okay? This was a good question. 1999 JEE. इतने simple questions are there. Okay. If you are done with this, then tell me. We will go to a new topic. I think in the test ka syllabus, it's mentioned that there is something called as total internal reflection that I have not taught you now. So I will teach you that today. I actually wanted to go on with lenses, but let's start with TIR. Are you done with this? Didn't get it. Alright. Did you get the logic? You can copy for now and try it later. All the questions that I do in the class, if you understand it, still try to do it at home once yourself by closing off the book and just looking at the question. Only when you do it now, only then you will get the confidence. Just by looking at things, you will never get the confidence to do it yourself. So it's not a theater, that is nothing. Should participate. Beginning. Sphere का कोई भी section pattern you will get a curve, but if I cut a very very small section, it will be a plane. Yes, can you imagine? It will look like a plane. So with respect to this plane, if I were to extend the whole thing and make a sphere, it's a very big. So it will look as if it's. Can I go forward? You have completed the solution? Great. Take the topic total internal reflection. Write with me. TIR. I will keep on calling it TIR more often than not that. It's a very fascinating thing. How you can apply Snell's law and how it helps us in real life. Let me ask you this. When rays goes from denser to rarer, then what happens? It bends away from the normal, right? So if I were to make a diagram something like this. You have a mu r, you have a mu d, and it's given that mu d is greater than mu r. That means this is a denser one, that is a rarer one. You have a ray coming out like this, making some angle I1. It refracts and gives some angle R1. Something like this, no? Away from the center? Away from the normal? Yes. Good. If I apply Snell's law, then what will I get there? What is Snell's law element? By Snell's law, mu d sin I1 is equal to mu r sin R1. Sin R1, yes? And if I write sin R1, that will be mu d by mu r sin I1. Yes. Now this mu's are just a number, no? They are just numbers. So this mu d by mu r is again just a number. Okay. Now let me ask you this. Whenever we consider the angles, in what domain do we consider? From what to what? From 0 to 90 degree. We only consider beyond 0 to 90 degree. Then what is the sine function behavior from 0 to 90 degree domain? It's an increasing function. Yes or no? It's an increasing function. Then, so between 0 degree to 90 degree, sine is an increasing function. Yes. That means if I increase I1, sine I1 will increase. The whole thing will increase. That means sine R1 will increase. That means R1 will increase. Yes or no? So let me write all of this in chronology. So I1 increases. This means sine I1 increases. That means sine R1 increases. And that means R1 increases. And what do I mean by all of this? That if I make this angle to be a little bigger, let's say I2, then where will my ray go? Will it go like this or like this? Like this, huh? The ray angle will increase, huh? It will increase. Yes? Then you should be sure with this, if I keep on increasing my eye, there will come an angle for which the R is perfectly 90 degree. Does this possibility exist? Yes, it does exist. So here, maybe you will find some angle. Let me call such an angle IC. And for that IC, what will my R will be? 90. So R will be 90 degree for IC. That IC is called the critical angle. Now, if you go beyond this IC, then what will happen? Then the ray will go downwards. Yes? Do you remember that when I told you that if there are two mediums separated by a boundary, a ray of light comes, then there is always partial reflection and partial refraction. I told you this? But when you go beyond this IC, is there any part of the ray which is going up? None of it is going up. Every part of it is going down. Let me show you by colors. So let's take the red color. If I go like this, then it will go like this now. Will it go? Will it refract? There is no refraction. It behaves as if it's a mirror. Yes or no? It's actually a boundary separating two media, but now it behaves like a mirror. And this phenomenon is called the total internal reflection. It's totally reflected, the rays. When you go beyond this angle IC, beyond this IC, if you are little lesser than IC, then refraction will occur. Does it make sense? So this IC is called the critical angle. If you go beyond critical angle, total internal reflection, that's TIR, occurs. If you are below IC, TIR does not occur. Does it make sense to you? Good. So for some I is equal to IC, R is equal to 90 degree. IC is called as critical angle. Does it make sense? It's called the critical angle. Then let me give you some notes now. For I which is greater than IC, TIR occurs. TIR occurs. For I less than IC, does not occur. And for I less equal to IC, this is the boundary case. The boundary case for which the rays are just going like this. Not refracting, not reflecting. Yes? Boundary case. Is it all okay? How can you calculate that IC? What does this IC depend on? let's try to find it by Snell's law. Then if I write I1 as IC, then what is my R? What is my R? I just wrote it. If my I is IC, then my R is 90 degree. Then if I apply the Snell's law, then what will I get? That mu D into sine IC is equal to mu R into sine 90 degree. What is sine of 90 now? Don't say 0. Plus 1. Then what will you find IC as? IC is equal to sine inverse of mu R. So as you can see, critical angle is a characteristic of the pair of mediums that you are taking. It depends on the refractive indices, and refractive indices do not change. They are characteristic of a medium. So IC depends on this. This is how you calculate IC. If you take the rarer medium to be air, then what can I write? Yes. If mu R is equal to 1 and mu D is equal to mu, then IC is very simply found sine inverse 1 over x. Fairly simple to find it. Is there any problem? Please remember this. This is a very important note that you should remember. That TIR only occurs when the rays are going from denser to rarer. Because only in the case of denser to rarer does the ray bends away from the normal, and there is a possibility it will come back. If you take the case of rarer to denser, bends towards the normal, is there a possibility it will reflect? No possibility, sir. So I should write this. TIR can only occur when rays goes from denser to rarer. Does it make sense to you? Yes? This is the only thing that is relevant for TIR. But now there is a very important thing which I was talking in when I started with the topic. How can you have such a very important application of Snell's law in real life? Then I should ask you this: for long distance communications, how do you, when you speak here, how does the information go there without any loss? होता है ना साहब? I speak here and then person who is standing 100 kilometers away listens to my voice and all the information very clearly. How does it all happen? Or maybe when you give off some information, let's say you want to do long distance translation, some signal from here to there, then how does this signal, why doesn't it get lost? या फिर उसमें कुछ बीच में losses क्यों नहीं होते? We use the principle of TIR. And let me tell you this, and the wire that you use, it's called the optical fiber. So optical fibers are something like this. What we do, I'm not going to talk about optical fiber at length or its structure or anything, but the optical fiber is something like this. It's a pipe-like wire. And now what do we apply? We apply the TIR. You incident your angle at such an angle such that only reflections, total internal reflections occur, there is no loss outside. So the way and the rays goes actually like this. And then they come out. There is no loss. It uses the principle of TIR. Okay? And I wanted to say something more. Yes, it does not matter if you bend your wire, if you close off your wire, it does not matter. TIR will still occur. That's the important thing. People will say, why are we doing like this? What if you have a straight wire? Straight wire, no. उसके बाद ऐसी rays भेज दो direct. But then if you bend, what does happen? So that's why we use DIRs and in DIR principle. Do you get it? You just have to remember this. Does it make sense? I'm done with the theory of TIR. You can start with sheet number 5, question number 1. Obviously, it's not. Nothing is 100%. There will be losses when the ray of light bumps into the wires. There will be heating. Due to that heating, loss of information will occur. Losses 100% efficient solution. The best we have is Carnot's engine. Even Carnot's engine is not 100% efficient. जाने मिलेगा नहीं समझा मैं ट्राई करूँगा. So let's start with sheet number 5, question number 1. I will start at 12:37. Don't worry about isotopic. It's a point. Just imagine it to be a point. Freedom purpose. What? So, is that recorded? If he doesn't come tomorrow, he won't sit in my lecture. It's 12:37. Anybody with any answers? Should I start with the problem or should I wait? Okay, I will wait one more minute and then I will start. Does it need a diagram for question number 1? Is it mentioned there? starting with sheet number 5 now. Wait a second. Correct. Good. I got one answer. Anybody else? Should I start then? Okay, starting with the question. What is the question asking? That you have a point source which is placed at the depth h below the surface of water, and a disk is placed on the surface of water so that the source is not visible. What is the meaning of it? Radius. Now try to imagine. Imagination is very important in this question. You have a water body, something like this, and at the bottom part there is a point source P. Let's say this will give off rays in all possible directions. All possible directions. Let's say one of the angles, this angle is coming out to be IC. This angle is IC. If you go for further rays, is this angle greater than IC or not? That is greater than IC. For that TIR will occur? Yes or no? For that TIR will occur. So will the ray of light come out? No. That is the meaning of total internal reflection. It comes inside, it never goes out. So I don't even have to worry about for the cases for which I is greater than IC. They will automatically be inside the water body. You know? For the cases for which I is less than IC, like this case, here the ray of light has a possibility to come out. You know? So you can imagine there are so many rays, and only for some of the rays that will create actually a cone. Can you imagine? It's a cone. For this cone, the rays of light has a possibility to come out, has a possibility to refract. And now what I am going to do, I am going to close this cone by some disk so that no ray of light comes out. So I am going to close this cone. What? And then they are asking what should be the radius of the cone so that no ray of light comes out. This is the question. Did you get the imagination of what I am asking? Okay. Now let's try to find that R. So ये है body, ये है कुछ point source P. It will give off this I. Let's say this is the case for which IC occurs. The same here, IC. You want a cone to actually block off everything. And what should be the radius of the cone? R. What is the depth of the thing going to be? H. Then I think I can make a triangle here. Can you see this? This triangle. And making the triangle again. This is IC. This is H. This is R. Any trigonometric function which relates this H and R? And tan से हो जाएगा ना? Opposite upon adjacent. Then what is tan? Tan R? What is tan IC? R by H. If only I knew this tan IC, then my question will be done. Because I will find my R. Now I want to find this IC. But do you have a formula for IC? Yes, we can apply the Snell's law maybe. We can apply Snell's law and then what will you get? By Snell's law. बताओ क्या होगा? Sin IC into what is the refractive index of this medium? Mu. That will be equal to what will be the angle of refraction? 90 degree. Sine 90. What is the refractive index of this thing? That's air. 1. Is there any problem with this? So this will come out to be 1 again. So what is sine IC then? 1 by A. If you know sine, can you make a triangle and find tan? Do you know how to do this? ये पता है कैसे करते हैं? एक triangle बनाओ. A right angle triangle. Find IC this. This is my IC. Then this is my opposite. This is my hypotenuse. So ये opposite, ये hypotenuse. Then what should be adjacent के वाली Pythagoras से आ जाएगा. Is it all okay? Then what will be tan IC from here? 1 by root. Then this tan IC and that tan IC are same. Then what will you get? R by H is equal to under root of this thing. And then what will be R? Yes. Very simple. I made one triangle and then I applied this condition of TIR. Okay? If you have understood, then copy. If you are done with question number 1, go for question number 3. Don't go for question number 2. Okay? Go for question number 3. What is your question number 3? Let me make the figure of 3. Is it written? Let me wait 1 minute and is the first part of it is written? The diagram. These things are given, and I think some more things are given. Yes, this is point Q. This is point B. This is mu1, this is mu2, I think. No, the other one is this one. This is one. Okay? ये question number 3 है ना? Attempt the question. Attempt करो, attempt. I will wait 3 minutes, then I will start. 12:50. Very easy question.
sugar.
Answers? How do you take? Answer. Yeah. Sin I is equal to that. So I is equal to what? I is equal to sin inverse of the whole thing. They are asking for I. And what is the answer? Yes, keep on writing, don't worry. Okay, we will write it. Change the options. Yes, anybody with the answer? Option D is correct. Option D. This was fairly simple. It's given that at point P, total internal reflection. What are they asking? Question number 3. So that it never takes place. So if I consider the boundary case where I is equal to IC, it's good enough for me. Okay? Never takes place is actually the case where I is less than IC, but I am going to talk about the boundary case. So I will have to apply TIR here, but what about here? For point Q, what to apply here? For point Q, by Snell's law, what can I say? It's mu2 sin I is equal to mu1 sin alpha. And what is sin I, by the way? It's mu1 by mu2 sin alpha. And I think they are asking about I. So I is equal to sin inverse mu1 by mu2 sin alpha. So already I am getting something which is resembling my options. sine inverse something or something. Now I have to find this alpha. But how to get that? For this point P, now look at this point P. For point P, what can I apply? TIR. From TIR, what can I say? That sine beta is actually equal to what? Mu Rayleigh or mu what upon what? Do you remember? Rayleigh by density. This is beta. Then what is beta equal to? Sine inverse of mu2 by mu1. Yes? mu2 by mu1. Is that all okay? Yes. But I have sine alpha, but can I find a relation between alpha and beta from this line? Alpha equal to 90 minus beta. So what will I get then? Sine inverse of mu1 by mu2, sine of 90 minus beta. What is sine 90 minus theta? That's cos theta, right? So I got in terms of beta. So cos beta. But what is beta? Sine inverse mu2 by mu1. And now I am done. It's very simple. Sine inverse of mu1 by mu2 cos of sine inverse of mu2 by mu1. This is my I. The options may look very hideous, but the process is fairly simple actually. Just apply transfer at one point, apply the TIR condition at other point, and then use the property of triangle. And everything is done. If you are done with this, go for question number 5. Question number 5. Is there any diagram of that? Diagram is needed. So let me make from here. Question 5 diagram. What is the question? Let me make the diagram something like this. This is the diagram at hand. This is theta, this is theta dash, theta double dash. They are asking to find, I think, theta. Some kind of condition on theta. Sorry, the maximum value of theta. इतना इसको हिलाना. Can I start with the question then? How many of you got the option A? Only one person. Others are trying. Okay, I will wait 2 more minutes and then I will start. Any answers? Okay, then I'm starting with the question. So,
Rakesh,
what is given in the question? That this medium is the air, right? I think it's air, and some kind of refraction occurs, and then at this surface, another refraction could have occurred, but here TIR occurs. Actually, it's given. TIR occurs at this point, and they are asking. Let me give some names here so that it is clear. Let's say this is point A, this is point B. For some angle of theta, this will occur, TIR will occur, and for some angles of theta, it won't occur. So we have to find a condition on this theta. Na? So let's try to do what we know. What do we know at point A? What can I apply? At point A, we apply Snell's law, and what do you get? So it's something like 1 into sine theta. Now what are you saying?
We can first apply TIR and then.
Hi, it's okay. Let me do it my way. Hopefully it will give the same answer. So 4 by 3 sine theta dash. Yes. So sine theta is equal to 4 by 3 sine theta dash. Yes. What is the relationship between theta dash and theta double dash?
90 degrees.
So I can write it 4 by 3 sine of 90 minus here theta double dash. You will get 4 by 3 cos theta double dash sine. Do you know this that in the domain from 0 to 90 degree, 0 to 90 degree के उसमें कर्व कैसा आता है? Cos theta का curve goes like this and sin theta का curve goes like this actually. Do you know this? Then when sin theta is max, this is sin theta का curve, this is cos theta का curve. When sin theta is maximum, that is what they are asking, na, maximum. Then what is cos theta? Minimum. So this should be minimum, na? The minimum angle for which the TIR occurs. So that is I equal to IC. At just that angle the TIR occurs. So for minimum theta double dash such that TIR occurs, the condition is something like what? Theta double dash is sine inverse of, बताओ, mu r by mu and let's say write it sin theta. So this will be 1 upon 4 by 3. This will be 3 by 4. If I know the sin theta double dash, can I find cos theta double dash? That's under root of 1 minus, no? So this will be 4 by 3 under root of 1 minus 3 by 4 the whole square. Can you tell me the calculation? What will I get? Root 7 by 4, huh? And that will be root 7 by 3. So this is the condition on sin theta. This is actually the maximum theta for which the DIR will occur, just occur.
So can we use the answer from question number 3 to do this question?
Question number 3. What is the answer in question number 3?
Like we found the result right that I should
But obviously who will remember that? So many verses. If you want, you can try and check if you get it or not. But applying Snell's law is very simple. Every time you get this refraction or a thing, you can apply Snell's law. So if you're done with question number 5, go for question number 4. Let me give you 4 minutes to think. Or rather 5 minutes. Take 5 minutes. That will be the last question of today. I will not discuss anything more than that. फिगर बना के देता हूँ. पहले ये हो गया क्या आधा? आप डन एटलीस्ट? कितना हो गया? Question number 4. Diagram. What is the diagram like? These things are mentioned, now try to do the question. So I will start at what time? I am giving you plenty of time. Try to get it fairly simple as well. That's question 5.
ब्रेकला చెప్తా.
Anybody with an answer of question number 4?
Sir, see,
What is C?
eta is not sign equals to.
Yes, I think that's correct. Under root mu2 square by mu square. Correct. Should I start then? Do you want me to wait? Start. There's nothing better than to give up. Good. Question number 4. What are they asking, by the way? In the question number 4, they are asking, this is a cube of side D made of some material mu2 and it's immersed in material mu1. A ray of light is incident on this and TIR occurs here at some point E. Let's call it point E. Okay, and let's call it point F. Yes? TIR occurs, then theta must satisfy what? Okay? Theta must satisfy what? So I am going to do the same procedure that I have been doing in the previous questions. What will I do here? What will I do here? TIR का condition. It's all the same. Everything is the same. Okay? So apply Snell's law here. What will I get here? At point F, mu1 sin theta is equal to mu2. Let's call it alpha. Okay? Let's call it alpha. That will be sin alpha. So I think you will get sin alpha as mu1 by mu2 sin theta. Yes? What is this angle, by the way? That's 90 minus alpha, na? 90 minus alpha. ठीक है. अच्छा, at point E, what will I get at point E? At point E, I can say that TIR will take place, and for that to happen, what can I write? For TIR to just take place, what will be the condition? That mu2 sine of 90 minus alpha should be equal to mu1 into sine of 90. Yes or no? And this should be mu2 sine of 90 minus alpha is equal to mu. This is the condition for TIR to just take place. But I think in the question you are going well beyond that angle. If you are going well beyond that angle, that means this factor is going to be greater than that thing. Does it make sense to you? If this were to be the angle for which the TIR just takes place, then this factor is equal to this. But if you are going greater than this angle, then the whole thing becomes greater and this becomes greater than this. Beyond TIR, beyond just TIR, these are not proper words maybe, but anyways, mu2 sine 90 minus alpha is greater than mu1. Yes or no? Now what is mu sine 90 minus alpha is what? That's cos alpha, that's greater than mu1 by mu2. Yes? mu1 by mu2. Now I already know what is sine alpha. Can I find cos alpha from here? What is cos alpha from here? under root of 1 minus mu1 by mu2 the whole square sine square theta. Yes or no? Can I substitute that here? Under root of 1 minus mu1 by mu2 the whole square sine square theta is greater than mu1 by mu2. Can you square and do the calculations, manipulations and find the condition of sine theta? What will be the final condition of sine theta? Can somebody tell me? After all the mathematics. Yes, Virupaka, tell me. What is the condition?
Under root mu square minus.
It's less than under root of
Mu square by mu square.
mu2 square minus 1. Is this correct? You should get this after all the things. Hopefully, please check if you get it or not. So I am not teaching anything more than this today. You can switch off the video.